Hello everyone and welcome to IB Mathlogy, your space for mastering IBDP mathematics. Now in today's video, I will be solving some past year paper questions on Maclaurin series topic. This is part 2 of my video. In part 1, I have introduced what exactly is Maclaurin and how to solve questions. So let's start with the first question. Now in this question, the function is e to the power x into sin x. So a part of the question says, find the Maclaurin series for fx up to and including x cube term. So this is basically multiplication of two functions. Now we have to recognize both the series. So let me write the series for you. You can see this from your formula booklet as well. 1 factorial plus x square over 2 factorial plus x cube over 3 factorial and so on. And for sin x, my series is x minus x cube over 3 factorial plus x to the power 5 over 5 factorial and so on. Now what I need to do is I have to multiply these two series. So I will be multiplying them, but I have to have x to the power 3 term. So I will simplify this and then write plus x cube by 6, this multiply by x minus x cube by 6 plus x to the power 5 over 120 and so on. Now since I need to get up to 3 terms, so I will be start multiplying this one with the bracket. So I will get x minus x cube over 6. Now my next thing is I will start multiplying this x with the bracket, the next bracket. So it will be x square because I only need this. Now I'll pay focus on x square by 2. So I will multiply this also with x. So this is also x square over x cube over 2. And now I cannot multiply this x cube over 6 with the next bracket because I only want up to and including x cube term. So this is basically, I have to stop here, and now I can solve these two. So I will get my final answer as x plus x square, and on taking LCM you will get x cube over 3. So I will write my answer like this. So this is my expansion of the Maclaurin series. Now let's move to the next part. Now in the next part, I have to find the approximated value of this. As we know that we just found out the answer as this, so I will be using this answer only. So I can integrate from 0 to 1 and I can substitute the value, the solved value which I got from the A part, and now it's easy for me to integrate this. So when I will integrate, I will get x square over 2, x cube over 3 plus x to the power 4 over 12, so on 1 to 0. Now when I'll put the limits, I will do upper limit minus lower limit. So I will get 1 over 2 plus 1 over 3 plus 1 over 12 minus 0. So this will give me an answer as 61 over 105. You can check this answer using your GDC also. Now in the next part, it says there is another function gx which is e to the power x cos x. Now show that gx satisfies the equation this. Now since it says satisfies the equation, so what we can do is, since it's double dash and single dash, so we will first find out the derivative of this gx. So let's start. So if I start by finding the first derivative, so I have to apply the product rule at least first. So I will keep e to the power x derivative will be e to the power x only, and cos x remains as it is. Then cos x derivative is minus sin x, so I can write it like this. Now I have to take another derivative, so I will again apply the power rule. So it will be e to the power x, derivative is e to the power x cos x as it is, minus e to the power x cos x derivative is minus sin x. Now I will be taking out derivative of this. Again I will keep sin x constant, e to the power x derivative is the same, minus again sin x derivative is cos x. Now here if you can see, these two will get cancelled out, so I will get minus 2 e to the power x sin x as my answer. Now I have to go back to this equation and let me first write this equation. So it says g dash x is equals to 2 times g dash x minus gx. So how will I start? I have all three values, so what I can do is I will first solve this because I have g double dash x value with me. So I will solve the right hand side. So it will be 2 times e to the power x cos x minus e to the power x sin x minus my gx was given to me as e to the power x cos x. So these two terms will get cancelled out and my final answer will be 2 e to the power x sin x, which is nothing but equal to my left hand side. So this is how we have shown. Now let's move to the next part. Now the next part says we have to reduce that g dash 4 times, it means is 2 times this. So again what we can do is, since we have from a part g double dash, so now it's your wish whether you want to find the 4 derivatives or not, but what we can do is I can write that third derivative of g dash x will be 2 times, I will just follow the pattern, second derivative minus the first derivative. So if I am talking about the fourth derivative, so it will automatically be third derivative minus the second derivative. So this is how I can write, although it is a 1 mark question, so it's easy for me to write like this instead of expanding up to power 4. Now in the D part it says using the result from part C, find the Maclaurin series of gx up to and including the x to the power 4 terms. Now since we are talking about Maclaurin series, so this part comes into picture where I have to substitute x is equals to 0 in all the derivatives. So I'll start with g0. So my gx was e to the power x cos x, so g0 will be 1, and when I'll put in my single derivative I will get again plus 1. When I'll put in my double derivative I will get 0 because I have sin 0. So in the triple derivative I will get minus 2. You can solve this, expand this, and then you can check your answers from here. Now we can attempt to substitute into the Maclaurin formula. So my Maclaurin formula says it was 1 plus x minus 2x cube over 3 factorial minus 4x to the power 4 over 4 factorial and so on. So when you are substituting you will get this. So this how I got, I used my formula booklet and from there I have taken out Maclaurin series expansion and then I have substituted the value. Now let's move to the next part. Now the last part says find the value of limit this. Now if you pay attention, e to the power x cos x expansion I can use. So I can write limit x tends to 0. Instead of e to the power x cos x, what I can write is the expansion which I got from above, that is this. You can check from the previous part, it was 6 and then keeps going. So this is the expansion which I can put minus 1 minus x whole over x cube. Now we can separate, we can apply L'Hopital and then we can solve it. So there is no need to apply L'Hopital, as when we will open this and these two will get cancelled out. So I am left with minus x cube over 3 minus x to the power 4 over 6 and so on divided by x cube. So x cube will get cancelled out and I am left with minus 1 Now in this question, this is question number 2, write down the first 3 terms of the binomial expansion. Now first part contains binomial expansion. After this we have Maclaurin questions. So you can use your binomial series expansion of a plus b to the power n. So according to this, I will get my expansion as this. You can check it. Now let's move to the next part. Now in B part it says, by using the Maclaurin series for cos x, which is there in your formula booklet, and the result of part A, we have to show that the Maclaurin series of sec x is this. So how we'll solve? First of all, let's write cos x expansion, that is 1 minus x square over 2 factorial plus x to the power 4 over 4 factorial and so on. So when I'll expand, this will be upon 2 plus x to the power 4 over 24 and so on. Now we all know that sec x is 1 over cos x. So what I can do is I can put this inside bracket and I can write, let t is equals to minus x square over 2 plus x to the power 4 over 24, like this. That's it. So what exactly this do is, so now I can write this thing as 1 plus t. So sec x is 1 upon cos x, so this also I can write like this, which becomes 1 plus t to the power minus 1. Now this answer comes into the picture, so I can write my sec x expansion as, it's 1 minus t, so my t is minus x square over 2 plus x to the power 4 over upon 24 t plus, it says t square, so x square over 2 x to the power 4 over 24 whole square and so on. So when you will simplify this, on simplification I can write it as 1 plus x square over 2 minus 4 over 24 plus, again I can apply a plus b whole square in this, so this will be a square plus b square, that is, but I don't need this because my question said up to term x to the power 4 only, so there is no need to write this. Now if I multiply 2ab also, there is no need, so I can leave my answer here only. Next I can take LCM and I can solve this further. So I will get 1 plus x square over 2. Let me take x to the power 4 common, so it will be 1 upon 4 minus 1 upon 24, which will give me my final answer as 1 plus x square over 2 plus 5x to the power 4 over 24. So this is the expansion of sec x. Now let's move to the last part of this question. Now in this question, by using Maclaurin series for arc tan x, which is there in your formula booklet, and results from part B, we have to write this. So let me first write what is arc tan x expansion. This is x minus x cube over 3 plus and so on. But I don't need this. I need arc tan 2x. So I will replace x by 2x. So this will be 2x whole cube over 3 and so on. Now just now I got my sec x expansion as 1 plus x square over 2 plus 5x to the power 4 over 24. So now what I can do is I can replace everything into limit. So x tends to 0. It says x arc tan 2x. So x multiply by arc tan 2x whole divided by, it says sec x minus 1. So I will substitute sec x value, which is this, minus 1. So this will get cancelled out, and then I can still take some x common, cancel out it, and then solve it. So this will be limit x tends to 0, 2x square minus 8x to the power 4 over 3 plus so on divided by x square by 2 plus 5x to the power 4 by 24. Now I can divide both numerator and denominator by x square. So after I am just simplifying. So after dividing, it will be this over, I am dividing by x square, 5x square over 24. Now when I will substitute the limit, my final answer will be 2 over 1 over 2, that is 4. So this is the final answer for the expansion. So this is all about past year paper, some questions from past year paper. I hope this video will help you clearing some doubts. If you have any other doubt or you want video on any of the topic, do let me know. Put it into the comment box, and please don't forget to like and subscribe to my channel. All the best everyone.